Right now, 400 kilometers above your head, Indian astronaut Shubhanshu Shukla is drinking water cleaner than your kitchen tap. But what might make you squirm is that water started as urine, sweat, and even exhaled breath. Today, we're diving into one of NASA's most ingenious achievements, turning human waste into pristine drinking water in space. It's not just clever engineering, it's keeping astronauts alive. Let's start with a mind-blowing fact. Every gallon of water sent to space costs about $10,000 to launch. That's more expensive than sending gold to orbit. And here's the kicker. Each astronaut needs about 1 gallon of water per day, not just for drinking, but for everything from regulating cabin temperature to shielding against deadly cosmic radiation. Now imagine you're heading to Mars. That's a 9-month journey each way, plus time on the surface. You'd need over 4,000 gallons of water for a crew of 6. That's not just impractical, it's impossible. This is why NASA's water recycling system isn't just impressive engineering. It's the difference between successful deep space exploration and staying trapped in Earth's orbit forever. Enter the Environmental Control and Life Support System, or ECLSS, arguably one of the most sophisticated pieces of technology ever built. This system doesn't just recycle water, it performs what can only be described as molecular-level magic. The system captures everything, and I mean everything. Urine from the bathroom, sweat from exercise, humidity from breathing, even water from washing. All of this gets fed into a complex network of processors that would make a chemistry lab jealous. The show's star is the urine processor assembly, which uses vacuum distillation to separate water from waste. But here's where it gets clever. Even the leftover brine, which still contains moisture, gets processed by the brine processor assembly. NASA's Christopher Brown puts it perfectly. Collect 100 pounds of water, lose only 2 pounds, and the other 98% just keeps going around and around. Before you get grossed out, let's talk about what recycled means in space. The brine processor assembly uses membrane technology and dry air to evaporate every last drop of water from waste. This humid air gets collected by dehumidifiers and sent to the water processor assembly. Here's where the real magic happens. The water processor assembly doesn't just filter the water, it uses a catalytic reactor to break down contaminants at the molecular level. The water is then tested for purity, and if it meets standards, iodine is added to prevent microbial growth. Canadian astronaut Chris Hadfield said it best in 2013. The water that we end up with is purer than most of the water you drink at home. And he's not exaggerating. NASA's current system achieves 98% water recovery, a 3 to 4% improvement from older systems, and every percentage point matters when you're talking about survival in deep space. But this isn't just about the International Space Station. As NASA engineer Jill Williamson explains, the regenerative ECLSS systems become ever more important as we go beyond low Earth orbit. The inability of resupply during exploration means we need to be able to reclaim all the resources the crew needs. This technology is our stepping stone to becoming a truly spacefaring civilization. Future missions to Mars, Europa, or interstellar space will depend on closed-loop life support systems like this. The water recycling system on the ISS is a proof of concept for humanity's expansion into the cosmos. Think about it. Every drop of water recycled on the ISS has brought us one step closer to making permanent human settlements beyond Earth not just possible, but sustainable. So the next time you turn on your tap at home, remember that 400 kilometers above you, astronauts are drinking water cleaner than yours. Water that started as waste, but ended up as liquid life support. It's not just about recycling. It's about reimagining what's possible when human ingenuity meets the ultimate frontier.